So, good afternoon, ladies and gentlemen. I'm Veronika Kusová, and I work at the Land Survey Office of the Czech Republic, and I would like to tell you about our experience with data and service validation using new INSPIRE reference validator. Land Survey Office started to provide first INSPIRE datasets and services in 2011, and we labeled them as INSPIRE compliant. But where were true, could we really introduce them as harmonized according to INSPIRE implementing rules and technical guidelines? Actually, at the beginning of a harmonization process, there were no ATS or ETS for some teams and services, so we could use simple validation against XML schema, but this method, you surely know, doesn't allow to check OCL constraint, so it wasn't so useful. Another method was manual inspection, or we could check the readability of the datasets and services by some GIS softwares, but we were limited by the restrictions of these kinds of softwares. As time went on, some validators, INSPIRE validators, were developed, but I have to say we use them quite rarely. And then 1 year ago, at the INSPIRE conference 2017, a new reference INSPIRE validator was released, and we were just like this, let's start testing. And after the conference, we really started testing our datasets and services. And I have to say that we didn't use REST API. We haven't tried to install the validator instance in our environment. And I've divided my presentation into two sections. The first deals with data validation, and the second is connected with validation of download services. From data, we validated all data via providers. So it was geographical names from Annex 1. It was geographical names, hydrography, and transport networks. Transport networks data are divided by application schemas into 5 separate data sets. And so it was tested separately. All our data are extended by ELF features and attributes if they exist. And before the validation process, all data sets were valid, or we knew that they were valid against XML schema and were readable in QGIS in version 2. And for the testing, we use all available test suites for these data teams. And now to the results. The percentage was counted as the ratio of the past test assertions. If the test ended as passed with manual check required, it was considered as successful. And you can see that cable transport networks dataset and water transport network datasets had the best results, so more than 90%. But on the other hand, road transport networks hit the worst with only 81%. And what types of errors did we have to deal with? I've created a simple list that consists from the most frequent and most important types of errors, and most of them appeared across all the tested data teams. So the first one, it was quite frequent. It was simple typographic mistakes. I show you an example. We misspelled, for example, word standardized, and these types of mistakes were really easy to fix them, so it's done it. The second group of mistakes was caused by validation against important XML schemas. In a dataset, there were feature or spatial object types that didn't originate from the schema that was mentioned in the schema location, because they were from the important schema. So during the validation, an error was raised. But if we put these schemas in the schema location, the validation is successful. So it's fixed now yet too. The third bunch of errors is connected with the proper form or proper form of coordinate reference system identificator. And the HTTP form of identificator is, according to INSPIRE requirements, the only one that can be used. And we use URN form on the shortened form like APSG and now the number of the coordinate system. But in most GIS softwares, the HTTP form of identificator or data with this identificator doesn't display correctly or didn't display correctly. So it was the main reason why we didn't implement it. Because I think it's a typical situation that when due to the INSPIRE requirements or other requirements, the usability of data can be really low because you cannot load it to any GIS software properly. But now QGIS in version 3 supports this form of coordinate reference system identificator, and we are testing it now, so we are going to implement it in a few months. But it's not yet done. And a last group of errors is connected with the validation of constraints, because simple validation against XML schema cannot display or cannot show the errors against data constraints, and we discovered a lot of them, but most of them were really easy to fix. But we came across with one important, let's call it as geometry issue, because it's connected with the geometry representation of line and polygon features, and it's not fixed yet, and I would like to tell you something more about this issue. For example, we have, standing water. It lies across the border of two export units, and for example this way, but standing water can be only geometry primitive, so it can be only these types according to XML schema. and according to data constraints, it can be only point, polygon, or surface. But if we cut the data according to sheets of export units, we get two separate polygons that belong to one one spatial object. So for us, there is no option how to fix it. And now, how the validator deals with extensions. The first picture shows the case of validation with ELF extension, and the second on the right side shows the data without ELF extension. It's the same data, but the right one was cleared from the ELF extension, and you can see that in some cases there is an error inside the own validator. And now about the download services validation. We validated our services, direct access download services. Our services are built on GeoMedia Web Map and GeoMedia SDI Pro as the software developed by a Hexagon company. And briefly about test suites. The main test suites consist from two parts. The first part test the conformance against WFS2, and it is an remote instance from OGC Validator Team Engine. And the second test suite is only the check of the capabilities document if there contains all the required conformance classes. And first results, our first validation attempt was really terrible because the main test use wasn't executed, and the second failed with one mistake. And then we find out that it was caused by invalid default reference system identifier, because only these two are allowed according to OGC standards. And so we fix it quite simply. And we started due to this problem, we started to use OGC Validator for WFS2 services alongside with INSPIRE reference validator, and I recommend it to you to try it because, for example, you can get get directly to the documentation of the mistakes and errors. And our first results, it was only 37%, and from simple WFS we have only 27%, and it was really terrible for us because we thought that our services were fully compliant to WFS 2 standards. So we did some testing and fixing, and currently our services are compatible with WFS 2 in more than 70%. And briefly about types of errors. The first group of errors, it was just simply ones because it was typographic mistakes in Git capabilities and some missing elements in Git capabilities, and it was really easy to fix. The second group of errors were caused by filtering, and it's fixed now too. And HTTP status codes for exception is not solved yet because OGC standards requires for body of exceptions HTTP status codes with code 400 and 430, but our servers uses 200 code. So, but we are communicated it with our service providers. And the next type of error is that the service returns features for invalid requests, and it's not fixed yet. We don't know how to solve it yet. And yeah, we should bear in mind that the validator don't have to be always right, because on the picture, on the bottom picture, you can see that for the filter property is equal to sensitive, the validator thinks that it's correct, but we knew that you don't receive any data, you receive an exception. And now to the conclusion, I think that INSPIRE Reference Validator is a really great tool. It helped us to fix a lot of errors, and in the future, we are thinking about using INSPIRE Validator as API for automatic testing, because I think it's a really interesting idea. And I want to say that it's really cool to have fully compliant data and services, but we should bear in mind that the data and services should be also useful for users. So if they are not able to, or if they are not readable in GIS software, they are not useful enough. So thank you for your attention.
Thanks. This one is a bit more flexible. Thanks a lot. This presentation goes a bit towards the direction Veronica already indicated. And we were also using the INSPIRE validator, but from the other side, from the API direction. And these few slides we would like to share with you as a sort of initial experience after, let's say, 1 year of intensive usage and testing. And you can see that it's not only me who is behind this effort and work, and there are also colleagues as Katarina Keti-Schleit and Tomáš Kliment, who are also significant members of this initiative. So here is the overview, what I would like to share with you, and why actually we decided to go to this direction. There are actually two main motivations. First one is that personally I'm representing the Ministry of Environment, which is responsible to make sure that Slovakia is providing the proper INSPIRE compliant metadata, data and services. And we saw that although European Commission already provided the graphical user interface for the validator, we realized that there are certain things which we were missing. And at the same time, knowing that there is API, we wanted to use this alternative channel to actually utilize the algorithm and the potential of the validator, but customize it to our national needs. So what we are missing the possibility to generate the graphical user interface which is localized in the Slovak language, which is a bit different approach than the one currently provided by the European Commission. And have to say that we wanted to have an interface which is more designed towards the users who are not the technical experts, who are more, let's say, domain experts. So in the positive sense, not very deeply GI oriented expertise. We wanted to store the results of the validation, and also we wanted to provide guidance for the stakeholders how to fix the identified issues. And of course, we want to make sure that whatever we are doing is helping us to to make sure that legislation is fulfilling its original mission and intention. At the same time, we started to interact with the crucial data providers, especially for the Annex 1 themes. As you are aware, there were some deadlines, and we saw that Slovakia has some serious gaps in this direction. So we were very happy to have this tool and actually to use it for direct interaction with those stakeholders to identify where the problem is, to help the problem fix, and on the end of the day, to have data and services as they shall be made available. As you can see on the last part of the slide, we still had to use the other tool already presented a few times during those days, mainly because of the support for the view services. So how it works, and of course there was also the other dimension of the usage of this API, and this was linked with the support for the stakeholders, because we realized that they were declaring that they are providing the services, but for certain reasons we couldn't see these services made available through the European geoportal. And at the same time, you know, the topic of validation is not the really trivial one, it's complex. And if you want to properly communicate it with the stakeholders, you have to find a way how to make it less, stressful, and make it more easier also for them to fix the identified gaps. So what did happen in practice? We realized that there are two types of gaps we are facing. First one was the group of functional gaps, where actually we wanted to ensure that using this API, which is published by the European Commission, we are able to provide three types of testing scenarios. First one is the execution of the testing via direct URI. It means that you paste the URI to the website, you press the button, and you can choose which test you execute on that particular resource. Then we have a specific possibility for users to decide that we have Slovakian National Catalog Service, which is providing the main channel of the Slovakian contribution to the European INSPIRE. And through that channel, we are providing the full text search possibility to type the keyword, and all of a sudden data providers see what are the metadata records available in the National Catalog Service, and they want to execute the test. The third option is the option dedicated for those data producers who already produce some services, some resources, but they knew that even those resources you can actually extract and generate the metadata directly from the capabilities of those resources. So I'm talking about the view, download, SOS services, and all this family of the OGC services. Then we wanted to make sure that actually, if there will be possibility to execute the tests, these tests will be integrated. So they will be not disconnected, that test for the metadata, test for the services, and test for the interoperability, but they will be clearly linked amongst each other. So you can see this mutual interaction. The second group of the gaps we identified was the sort of interface for the users, because we have a lot of data producers who are still really facing to the language challenge. So we want to make sure that they are able to use Slovak language to interact with the service, and also to actually create this possibility to see this interlinkage of the INSPIRE resources from the service capabilities. So this is the last scenario mentioned. And also we know that the European Commission has certain limitations how long they are able to keep the reports. But for us, it's very important to have the time span when the test was executed, and also in communication with the stakeholders, to be able to see the progress. So it means that we send them the report. They made some fixation of the problem. Again, the test was executed and we saw the difference. So that was also very useful. So how the app looks like, it's very simple graphical user interface where you can see it's split into mainly two parts. On the top part, you can, of course, find the URI for the application. There is also a source code shared on the GitLab, so anybody can have a look and try to see if it makes sense to customize it for their needs. And on the top part, you see this sort of entry box where you can enter either the URI for the metadata record of the particular resource. You can search through the national catalog service, or you can regenerate the metadata from the get capabilities. And on the bottom part, you see the four main sections starting from metadata to the services. Then it's network services. Then you have spatial data services and interoperability itself. So it's kept in one package. And how it works? This first example is showing that, for example, we typed to the search area the keyword indicating the shortcut for the National Mapping Agency, and that we are looking for the resources which are related to the INSPIRE. And immediately you get the response from the National Catalog Service offering you what kind of resources are already described via metadata. Then you choose, in this case, it's relatively small, but I think it was download service for the hydrography. And when you choose this particular metadata record, the system allows you to actually prepare all the tests you can execute on this resource from the metadata to the data interoperability itself. So on the end of that chain, you see all those options. At this moment, the part for spatial data services is not active because in this case it's download services, so it's an instance of the INSPIRE network service. Then you can choose whether you want to execute the test on the metadata level or any other level, or you can also run all the tests for all part of this, let's call it resource channel. The last option is this extraction from the get capabilities, which in principle follows the same scenario. And this allows also the data publishers to speed up the process of the generation of the metadata in case they would like to do it with the help of this tool. The results are visible in the middle part of the screen, where after the tests were executed, it means this application communicates with the API in ISPRA, in the European Commission. The results of the tests were returned back, and user can either display this HTML representation of the results, or there is a possibility to have the log version of the results. This is the part which is currently offering the storage of the results of the test. At this moment, we are keeping them on the standard folder structure with the identification of stakeholders based on the certain specific Slovakian identifier. And here you can find all the testing reports which were executed in the past. With this slide, we would like to show you what was the impact of the usage of this tool in Slovakia for the recent period. Some of you know these figures. These figures were shared with us by the colleagues from the European Commission. And on the left side, you see the progress in the time, but you have to read it from the right to the left. So on the right side, you see the status of the availability of the download services from Slovakia in March this year, where we had 0. So we had nothing visible from Slovakia in INSPIRE from the European perspective. So we started to do this validation exercise, interaction with the stakeholders, and slowly you can see the progress. And on the end of this period, it's somewhere in the May, we were able to really cover the most of the INSPIRE themes. There are still some themes to be properly finished, but in a relatively very short time, I'm talking about let's say quarter of year or maybe half a year, we were able to significantly improve the situation and visibility of the INSPIRE resources from the national level towards the Europe. And the same applies for the right table, which is indicating the information about the priority data sets. So we were quite happy that with this tool, we were able in a short time to fulfill something what was not possible to do a long time before. And what we would like to do in the future, we would like to focus on the improvement of the functional offer of that solution. It means to follow the development on the European validator. So as soon the new functionality will be available, we would extend also this graphical user interface. Plus, we want to integrate this solution to the sort of platform we are planning to provide the stakeholders on the national level in the near future if we will get sufficient funding. Anyway, we want to continue on the development of this tool because it's very useful for us. It helps us better coordinate the stakeholders, provide the support, and we want to also extend certain functionality like searching and extracting of the information from the catalog services endpoint. For the content, we want to really go for the things you can see. I'm not going to read them, but really for us it's important to make sure that on the end of the day, this tool will fulfill its original purpose. So it will help us to make sure that the data are properly provided to the infrastructure itself. So that's it from my side. Thanks a lot for your attention.
Thank you, Martin, for a nice presentation. I have one question, whether you are also thinking about extending the set of tests that are provided currently, maybe to address some of your specific needs in Slovakia. So to go a little bit, because that was one of the goal of this reference validator, let's say, system, that it's extensible to address also the national needs.
If you refer to tests which are supporting the extensions, yes, we would love to have it, but currently we still need to have a proper communication with the relevant data producers, with whom we think it makes sense to really start to work on the extensions. But at this moment in Slovakia, we have no concrete examples where INSPIRE themes were extended following the national requirements. But what I said with this connection to the e-government activities for the next 2-3 years, we see very strong demand for this kind of requirements, and therefore if it will be valid and relevant, we would have to do that. So definitely. And the last maybe thing which I forgot to mention is for us maybe some curiosity, if I may ask from you as an audience, if you are aware that in your country there are some plans to use the API for the validation for the future. That would be interesting to see whether we are really alone or some other countries are planning to work on the direction. So if you could raise your hand, that some of you, okay? Okay, so we'll be not big group, but good to know that we will be not alone. Thanks a lot.
Hello, good afternoon. I'm going to talk about how to use the ATS and ETS to perform quality control in the XMLs related with INSPIRE. This is the agenda. I'm going to talk about the good, the bad, and the ugly. The ATS are the good. Why they are the good is because they help us to develop the tests. What is an ATS? Is a set of conformance classes that define tests for all requirements of a specification. Here you have an URL of the technical guideline for metadata. And in this little example that we are going to do, we are going to see how to do a test of lineage, data encoding, and bounding box. It's a very small, very few tests, but it will help to understand. The ATS are stored in the GitHub project of the INSPIRE validator, which is an open source project. You can go there and get benefit from the project. Let's go with the good. In the left side, you can see the box that is in the technical guideline, and it says the requirement, in this case, the 1.11 about lineage. And in the right side, you can see the ATS, which you can see in the GitHub project of the INSPIRE validator, and it describes very well. You have here everything that you need to perform the test. The purpose, for example, which is if the type of the resource was a dataset or series, exactly one explanation about the lineage or datasets must be given. You can see as well what is the method, what are the references. As I said, this comes from the technical guideline of metadata, and some notes that it will help you to understand better the behavior of the test. And the last part is very important, because when you are going to develop the test, you need to know this XPath expression, which it will give you the values of the XML. This is the lineage. The same with the data encoding. In the left side, the technical guideline, who tells you what do you have to do. In the right side, the ATS is a well-described explanation about what the test has to do, what is the method, and again, these XPath references, which will help you a lot during the development. And the last one, in this example, is the bounding box. And you can see here how to do the test, in this case, to be sure that the bounding box coordinates are within a range with 2 decimals and that. And at the end, again, the XML element that you have to extract. Okay, this is the good. Let's go with the bad. The bad is the ETS, because it takes a lot of time. You have to deal with it, and it's complicated to do it properly. That's why it's the bad, and it's going to tell you what are you doing wrong. Okay, so ETS means a set of executable test cases. The first step that you have to do is to choose a tool. You can use, for example, and I recommend it, the GitHub project, the validator project, which is there, open source, you can use it, but you can choose another tool or another language. In this case, for this example, we chose FME, which is easier to explain for this example. Once you choose your favorite tool or your favorite language, you have to build an XQuery code to extract the values from the XML, and then you evaluate the results. Okay, so let's go with the project. In this case, it's a simple project with FME, which will perform 3 tests: lineage, data encoding, and bounding box. You can see the workflow there with the transformers. I don't know if you know FME. Those are the transformers. So you perform the test, and you get, depending on the results, you get, in this case, the outcome is an HTML file that will tell you, will store the results. So specifically, going zooming into the lineage, the first part, as I said, is to build that X query that will extract the information, and then we check with that value that we get if here hierarchy level is dataset or series, and once we get that, if it is a dataset or series, we check if the statement has a value and is correct, and it gives you it gives us a result. With data encoding, the same. The first part, we get those elements of the XML, and we evaluate them. Again, as the ATS says, we check first if there is a dataset or series, and then if contain a distribution format element, and if it contains in distribution format, we go and we check the name and the version. In this case, if the name is correct, it is not empty, and if the version is correct and is not empty. The last example with bounding box, again, we get the bounding box. In this case, we get the four coordinates. We check if there is a data set. We see if we have at least one bounding box. We check if in the bounding box we have 4 coordinates, and we check if the coordinates are decimal within the range, and the precision that we have is at least 2 decimals. So we do this, and with this we have the results, which only can be the ugly, because there is always something red, and we have to deal with it. In this case, we did an very simple HTML file with FME or with any other language. You can write in a database. You can send it by email. You can do it with more detail, telling you what is the line, where the problem is, etc. So, as a summary, we have the technical guidelines. We get the requirements from the technical guidelines. We develop the ATS. In this case, we can get them directly from the INSPIRE Validator open source project. We develop the ETS in 2 parts. First, we get the XML data from the specific elements that we need, and then we evaluate them, and then we get the results. And that's all. Just as a curiosity, this movie was filmed in Spain, in Burgos. You have here a tour with this application, which is Wikilog, and you can visit with the bike all the scenes. And I think this Wikilog is a good example because it's an application that a lot of people who likes going and biking and running and that use. And I don't know if you realize they don't use Google. They are using the Spanish SDI. So it's a good example that when the information is good, the companies use them. That's all. I just want to do something. I don't know if it will work. So each time you perform a check, anyway, I'm sure you can guess what was the song. Thank you very much.
Hello, I'm Paloma Baz. I show us the validation of spatial dataset and service metadata in Spain. Well, I work in National Center of Geographic Information, and it has some functions about directive INSPIRE. Someone is point of contact on INSPIRE and is responsible for monitoring and reporting in Spain. For example, Spain's dataset is showing in Thematic Viewer. and approximately 21% of the spatial dataset complied with the specification of INSPIRE. The second function publishes geographic information to deliver the dataset in conformity with INSPIRE in order to better find, access, and use them. What are their dataset? The datasets are from National Geographic Institute. We tell us what the difficult are the steps to publish dataset according with INSPIRE. We have 9 datasets. Geographic name, administrative unit, address, geography. This dataset is showing in thematic viewer. All of them have national coverage and Creative Commons license. But this? And all themes we have. All themes have a webmap service and web feature service, except orthoimagery and elevation. We don't have web coverage service and ATOM. And in the near future, have we finished the spec implementation? No, the answer is not, because the direct access download service is easy. There aren't any problems, but predefined dataset download service using the web feature service is difficult. We don't know how to provide predefined stored queries in web feature service to access features. We use degree tools. And ATOM have a lot of problems. It depends on the theme. For example, the transport network and infography have 1,000 features types, while geographic names and administrative units have few files. The webmap service is very easy, no problem, nothing, nada. Only the user don't work with the harmonized style of the layers like road link. What is the road link? The user wants or prefers common tiles like highway or store road. The webmap tile service isn't problems, but can be INSPIRE compliant because the layer names aren't harmonized names. Why? Because the layers are made up of a lot of layers. We don't webmap tile service about hydrography or network service because they have a lot of tiles without information, white tiles. This table is summary accessibility of a spatial dataset through view and down service. All themes have webmap service and direct access web feature service, but no predefined dataset download service using the web feature service. For example, in ATOM and in transport network and hydrography is very difficult. There are more 1 million road links with ATOM, and this information is not useful for you. This slide is important because you have 5 elements: dataset metadata, webmap service capabilities, web feature service capabilities, and webmap service metadata, and web feature service metadata, and 5 parts is necessary to connect. The all validation, the result browsers, detects the lack of interoperability between spatial dataset, view, and download service. If you connect all parts, you can answer this question. For example, how are datasets linked to view and download service? Or how can we download features from dataset metadata? This is the all tools and the result browser validation and has to pass conforming metadata and interoperability. A spatial dataset is considered interoperable if the following requirements are verified at 6 requirements. One, I would like to show an example. For example, you have a dataset has 2 spatial object types, administrative units and administrative boundary. You have webmap service, has 2 layers, and web feature service has 2 feature types. How many metadata files do you have to create? We have only 3 metadatas with scenario 1. It's possible in the future we change the scenario 2. Then 1 dataset metadata. We don't create layers about and feature type metadata. Why? Because the metadata elements are the same except the title and abstract. The author, bounding box, reference system quality is the same value. Only one metadata file to describe all resource. For example, this is a dataset metadata. You define all codes of the resource. For example, the first is the code of dataset, the second is the code of the first layers, and the third is the code of the third layers. Then you need to define the only result, the endpoint of the webmaster service and the web feature service in the same metadata. This is webmaster service get capabilities response. This in each layer must have you define the codes and authority you define in the dataset metadata. In the web feature service get capabilities, in the extend capabilities, you define the code of the dataset. And the metadata and the service metadata, you define the corporate resource to link the dataset, or the dataset layers, or the dataset feature types. Well, if you connect all your layers and your feature types, show on thematic viewer. If you need a map, a table map, a control map, you need all codes, all identifiers, all layers, or feature types. And I've just finished, and my conclusion is I would like the Commission provide a sample, a good example about dataset, webmaster service, web feature service, get capabilities with a lot of the layers with feature service. It should facilitate our work, because in thematic viewer, this year I entered in the Czech, Malta, French. Well, all components must be strongly linked. Is very great benefit. And I would like the new validator consider the interoperability and connectivity in the different resources. And my organization are working hard to implement INSPIRE. In 2010, we report more 4,000 metadata files, and the dataset conformity were 1%. And now, we report only 448 metadata files, but the dataset conformity is 21%. The network service conformity is better, is 81%, but accessibility of special datasets through view and download service is 64%. Thank you very much.
It's more a comment than a question. I like your presentation because it's really water on our mills, as you say that. I don't know if you've seen it, but we have been working on exactly this topic of simplifying or kind of disentangling the data service linking and how you do it in metadata over the summer. And we put some ideas in a discussion paper on how things could be really dramatically simplified. And we shared that with the MICT and the validation subgroup. I don't know if it has reached you as well, but if not, I suggest that you talk to your Spanish colleagues to have a look at that document, because it really is trying to kind of sort out the difficulties and make it easier for you, but also for us to actually establish the link between the data and the services.
So good afternoon, everyone. So validation of INSPIRE data by IGN. I have not myself make the validation. I have very small contribution. I am just reporting the work of my colleague. So as a short introduction, the plan, I will make a very short reminder about what is our transformation process. And for us, the validation, we validate against INSPIRE requirement, but we validate also the data against source data, validated not only the structure, but also the content. And of course, some conclusions with the main learnings. So our transformation process is quite classical. We have our source data. We make matching tables. From these matching tables, we have automatic script to transform the data into a database with an INSPIRE-like model. and then with configuration file, we make WFS for degree. So really something very, very classical in the transformation process. So the first point, as all of you, we try to validate our data against the INSPIRE requirements. So we use the INSPIRE official validator. We use the solution online, on internet. We perform mainly the test related to application schema, to reference system, and data consistency, at least those who are automatic. And those who are testing are those who are in charge of setting up the web feature service. It's the same team that is setting up the services and making the automatic validation. In the methodology, the first point is about selecting sample data. As we do it on internet, of course, we don't run the test on the whole data set with millions of objects, but just on a very small sample features. So in the general case, we just take the first features of each feature type, generally a very small number, maybe 10 features. And in case of association, the validator is able to find the related target features on internet, so there is no need to take care of interrelation between different feature types. There is a specific case that is about networks, for instance, for us, about transport network and hydrography, because there is a specific rule saying that nodes should be end or start of links, but without saying of which links. So in this case, we have to have the nodes and the links in the same area. So we have to use the bounding box approach for selecting links and nodes in the same area. Then we run the test, of course. We analyze the results. If there is no error, no action. And if error, we have to understand where it comes from. And sometimes, of course, related to our transformation process, sometimes the guy who validates the data can make the correction himself, or sometimes he has to bring the error back in the transformation process. Regarding the learnings using INSPIRE Validator, what is really nice, it's something automatic. The version is stable since last year, and the error message have becoming understandable. Sometimes they are not so easy, but at least you can understand them. What is maybe not so nice, it's the validation time. Even with 10 features, it takes a few minutes, maybe 1, 2, 3 minutes to validate a very small number of features. And of course, when using it on internet, you have to publish the data on internet before validation. So there is a risk to publish bad data. To be honest, the risk is limited because there are not so many users jumping on INSPIRE data at the moment. At the moment. So as potential improvement, regarding this validation against INSPIRE, we are thinking about using the INSPIRE validator, uploading it in our local environment. So we might validate data before publication, so providing more compliant data, be sure we have compliant data before publication, and also it will enable us to make the validation process more automatic. But I understood that the tool is not so easy to be installed, so it's not yet done. Regarding the second part of validation, we are really willing to test the INSPIRE data by comparing it to source data. Why? Of course, it's to ensure the data content quality. It's something we do for each of our external products, so we do it also for INSPIRE data, and I will say we do it maybe even more for INSPIRE because the transformation process is rather complex. The source model is rather far from the target model, so there are many opportunities to make errors. It's also, the purpose is also to validate our transformation process, see if our scripts are the right one or if we have made some errors. Of course, the context, it depends on source data and on matching rules, so it's something very specific, and we cannot rely on any common tools. We have to make the solution ourselves, and if you are willing to do the same as us, you have also to provide your homemade solution. So the methodology, we make a testing plan. We prepare some test suite on FME. So in a way, we make our own validator. And we extract, once again, sample data. We run the test and send report test for validation or error corrections. Once again, I have put the extract sample data in bold because it's a significant part in the process. So the testing plan is something rather not so simple, but at least it's just paperwork. It transforms matching table into test. It's done by INSPIRE experts, namely myself. In fact, our testing plan is not really exhaustive. We are not really aiming to check everything, especially, for instance, treatment of void attributes that we are not feeling, we are not so exhaustive on it. Maybe we test one or two examples and that's all. We are really testing when we have real value to be provided in the attribute. So you can see the matching table, it's an Excel table, and the testing plan, it's just a Word document showing which attributes we are really feeling and proposing some tests for the testing plan. Then we built the test suite on FME by comparing INSPIRE data to source data and using, of course, all these rich FME functions. And from this, we built some error reports. For instance, here you can see the test for validating identifier. And once again, what is really tricky is to extract sample data. So for testing against source data, we are willing to test it on a representative data with as many cases as possible. For instance, in code list, trying to have a sample data with all the values or at least most of the values. So we need not 10 features, but we need more features. Typically, we are aiming to have the 5,000 features allowed by Web Feature Service. So what we do, we make the selection in source data. We see, for instance, for the main feature type, for instance, for road transport, we are seeing, examining the feature type corresponding to road link, because it's the most represented feature type for road transport. So we try to find an area with more or less 5,000 objects, and it's the areas that will give us the bounding box. And then we try to get the corresponding feature in INSPIRE. So the first case, that is the simpler one, we have an isolated feature type with a geometry, no association, for instance, the land-water boundary. So we can use a simple URL request, and the Web Feature Service will give us, without any difficulties, the 5,000 objects that we require to make the test. Second case, it's not really very complex. We have a feature type with geometry and with some associated features. For instance, the address that is related to address component. In this case, there is some magic formula that is a resolve depth that allows the web feature to get the related features. And the depth is, you are getting you friends, it's resolve depth equal 1, but not the friends of you friends that will be resolve depth equal 2. So we just get the related features only once. And with this, for instance, we can get all the address with their address component. not so difficult. More difficult, we have a feature type without geometry, big number of instances, for instance, the transport property. And in this case, it's very complex because the relation is from the transport property to the road link. So the road link, it's easy. It's spatial feature, really spatial feature type. But to get the properties, in fact, the tool has to scan the whole list of, for instance, form of way. And for us, we have as many features related to form of way as road links, because we have a feature for each property, for each road link and each property. So we have to go through the maybe 1 million objects, and generally it's very complex. The server stops at one moment or another. So in this case, it really doesn't work smoothly. So what we do sometimes, if we have a feature type without geometry but limited number of instances, for instance, a small set of 5,000 features, such for instance as road, the association is still from road to road link, but in this case, as there are not so many roads, what we do a sequence of requests, and so we upload all the roads for making our test. And then we make the selection on the GIS, on FME. So as a result, I am not going to explain how we run the test because it's just automatic. Which kind of errors have we found? Sometimes significant errors, such as forgetting feature type. Of course, it's quite rare, but it has occurred. We have found a few transformation errors, for instance, in code list, or making things also with Boolean inversion of values. But what is most common is editorial errors, such as writing convention. And also, it was very useful because sometimes we have discovered errors in the matching table. When preparing the testing plan, why is there this rule? It looks curious, and sometimes we have discovered errors in our transformation process. So validation against source data, we consider it really as a necessary exercise because without it, we would have published data with some issues. Not a big number of issues, but some of them. So as general conclusions, in our opinion, data should be validated not only against INSPIRE to ensure conformity, but also against source data to ensure the content quality, that we are not degraded the quality of our data in the transformation process. The validation against INSPIRE is quite easier with the INSPIRE validator than with our previous tool. We used XML Spire, and it was really tricky to use it. But one conclusion is that the main difficulty is to get INSPIRE data from web feature service. We have developed various strategies to extract relevant sample data to perform the test. We don't really know if, because of web feature service has not enough functionality, or because we don't have enough knowledge about it, but as a result, it was a difficult exercise. So thanks for your attention.
Thank you very much. Are you publishing the results of this validation, especially these ones against the source data, as in the lineage of the data sets? Or at least are you thinking of publishing the methodology that you apply to validate the transform data against the source data? Because that's the lineage, that's exactly what the lineage should be for.
No, we were not thinking about this. What we were rather thinking about, it was rather to to use this kind of information about informing which attributes are really filled. We were thinking maybe it might be used to complete the information. Of course, there is an INSPIRE data specification, but this kind of information about what is the real content could be added to the data specification. We don't really know how it might work, but it's what we had in mind to make benefit of this exercise, to inform about which are the populated attributes.
It would be a useful information for users of the final transformed datasets to know that this dataset has been validated against the resource data. You know, at least, I don't know, some kind of a summary of this.
Yes,
it's a quality information, you know, at the end.
We had not yet thought about it, but I am not saying that we are not going to think about it.
Can you elaborate a little more on the last line on your conclusions when you were saying that the main difficulty was to get INSPIRE data? The main difficulty is to get INSPIRE data from WFS. What were the difficulties that you found?
Of course, there is this maximum number of features, but really the main difficulty is to get, for instance, the transport properties, because I think it's because of the direction of the link. You cannot get the transport property directly because it has no geometry, and to get the transport property related to the bounding box, there is a need to scan the whole file of transport property. And as there are millions, I'm not sure about millions, but at least a big number of features, it's taking a lot of time, and the server stops, and our testing guy, it's really a nightmare for him.
Okay, if there isn't... Yeah, Martin?
Maybe this, with reaction to this performance, I would like to ask colleagues from European Commission, and apologies that I didn't raise this question during the dedicated session. But are you aware during the first question is that if the users are using the graphical user interface, the communication beyond that interface use the same API than we are using, or is the different communication? And the second question, whether you were able also to monitor the workload of the usage of the tool. For example, if there were executed a test with really huge data sets, which might have an impact on the performance of the instance, and whether you occurred some limitation in that direction. Thanks a lot.
Yeah, so basically the API is the same that is used from the user interface, that the one that you can access remotely. There is an API call that actually is you can call to ask the status of the server. So I think it's called status as the API call, and that basically gives you some indication on how many processes are running, or how much memory is still free, and so on. We're currently looking into the performance issue because it's clear that is one of the main issues with the instance that we have running at JRC. We're looking into the code to see whether the code can be improved to actually allow more parallel tests running and so on. But we're also looking into cloud deployment of the solution to see whether that could be something to have better performance in the future. But to the question that Dominique raised about you have to publish your data somewhere in order to use the public instance. It's clear that the tool has been designed to also be deployed inside your own organization. So if you don't want to share data across the net because it's private or it's sensitive, or because it's big, there's always the option to deploy the tool inside your own organization.
Shall that be the final remark? Because then I will say thanks to all the speakers, and thanks to you, the audience, and yeah, have a nice evening.